More on the remainder theorem. In the previous video I ended up writing this f of x being equivalent to the divisor times the quotient at the remainder. In terms of the function, the polynomial being divided by the linear function, we had f of x was actually x cubed minus 7x squared at 6x minus 2. That's actually equivalent to x minus 2. Our quotient x squared minus 5x minus 4, and our remainder is 10. So this was f of x. So the divisor times the quotient add the remainder gives us our function. Now if we substitute a for x in this identity, then this becomes 0 and all of this becomes 0 and we're just left with r. So if we write that f of a is now equal to r, because we substituted in terms of x, we substituted a, which sends all of this to 0, we're just left with r. Now this result is known as the remainder theorem. So it states that when f of x is divided by x minus a is divided by x minus a. That's the linear function. In this case it was x minus 2. The remainder is f of a. So just to recap, I've stated algebraically what f of x is equivalent to, which is x minus a, its divisor times its quotient at the remainder. And we've expressed that in terms of the function polynomial and the linear function that we used. Here we found f of a, that's substituting a for x, and that sends all of this to 0, and we just know that now f of a is actually r. And this is the formal statement of the remainder theorem, is when f of x is divided by x minus a, the remainder is f of a. Thanks for watching this video. My name is Alistair. Any questions, comments or requests are all welcome. Please like and don't forget to follow or subscribe for more videos like this. Bye for now.